So now we bring the story of Manchester's economic, social and technological history right up to date. We're here in the Manchester Institute of Biotechnology at the University of Manchester, and we're going to discuss for a few minutes the topic of synthetic biology, which is a new emerging area and field of technology which brings into play all kinds of societal questions and responsibilities. And I'm joined today by Professor Rainer Breitling, who is Professor of Systems Biology at the Institute of Biotechnology. Could I ask you, Rainer, what is synthetic biology and how does it differ from previous platform technologies like genetic modification, for example?
Well, synthetic biology is very many different things to different people. It's very difficult to pin down with a single definition. It's the engineering of biology, or it's extreme genetic modification. It's an expansion of genetic modification technologies where things become faster and easier. For us in Manchester, it's mostly biotechnology 2.0, the next generation of biotechnology. We are interested in engineering microbes to produce new compounds, interesting functionalities that we want to use for industrial purposes.
And what kinds of applications or examples do you think synthetic biology might be used for?
Well, at the present time here in Manchester, we are mostly interested in using them as chemical factories, basically replacing the petrochemical industry. We are using microbes, engineering them to produce valuable compounds like drugs to treat diseases. We are using them to produce biofuels, again replacing the traditional petrochemical industry. But one can think much bigger, one can engineer much more ambitiously. We can, for instance, engineer microbes so that they don't need sugar to grow, but they can grow on waste products. They can use straw or wood chips as their feeding stock, and they can convert those low-cost materials into high-value chemicals that we are using for bioindustrial purposes. But one can go even one step further, engineering them for health purposes. We can think of engineering microbes to inject into the bloodstream of a patient with cancer. The bacteria swim around in the blood, they detect the cancer cells and in a localized way produce a drug to kill the cancer cell in the patient, targeted specifically for this individual type of cancer. Those are more ambitious, futuristic applications. At the moment, we are mostly focusing on the industrial controlled and contained use of microbes. So having reactors, bioreactors in which microbes are growing and producing what we are interested in.
That's really interesting, but therefore what kind of societal responsibilities do you think this new area of science technology brings? What kind of risks? What kind of anticipated impacts for society?
Well, you can imagine if you have a technology that's the next generation of genetic modification, there's a large debate about the safety of the technology. Is it safe to engineer microbes? If we can do it faster, if we can have more complex manipulations of the genome, will that result in microbes that are doing things that we didn't expect them to do? Can we predict what they do? Can we predict their properties? Can we prevent that they escape? Can we prevent that they have an impact on the ecosystem? There's the same discussion that we had with GMOs, but now on a larger scale. There's a large discussion also about the security aspects. If we can engineer living systems, we can potentially engineer living systems with unpleasant properties, bioweapons in particular. We can synthesize viruses, we can synthesize microbes with pathogenic properties. Can we prevent that? And the main aspect of synthetic biology is that it simplifies all of this. It makes it much easier, it makes it much more accessible to a wider range of players. It's no longer necessary to have an academic research lab to do genetic modifications. It's not necessary to be a big pharmaceutical company to be involved in synthetic biology. You have far more people involved in the field, and that creates a much richer potential societal debate.
So we've covered the kind of opportunities and now some of the risks and challenges of this new platform technology. But what do we do next? Who is going to take responsibility for the responsibility of synthetic biology?
But Again, if people are becoming involved in this field of genetic manipulation that have not been involved before, all of them have to take responsibility. All of them have to be aware of the potential impacts. To take an extreme example, people have suggested using synthetic biology for recreational purposes, for art. It seems very innocuous, it seems very innocent to do that, but people have to realize that they are still manipulating the genomes of organisms, that they have to apply the same rigor in assessing the activities as you would do if you were a multinational company that is producing a new drug or a genetically modified plant or food. So there will be far more discussion required, far more people have to be involved, and because it's an accessible technology, it will spread. The applications of synthetic biology will be much more diverse than they have been for genetic modification. Because it's much easier to do, much faster to do, we can try many more things than were possible before. All of that has to be accompanied by a societal debate. We have to make people aware of these developments, because scientists can't really make decisions about value questions. I think that is a very important aspect. We can advise on potential impacts on safety and security. We can tell people what is possible and what projected physical damages might be, but we can't decide on the societal decisions. Those are value questions. People have to decide their priorities. They have to decide whether they put food security above biodiversity. They have to decide whether they consider a risk of a technology more important than the economic potential that it creates. And they have to decide that not only for their own society, but also in the global context.
And that's interesting, because that brings in distributional questions. So is this a debate just for the rich West countries, or what is the role or applications for developing countries?
Synthetic biology makes genetic modification available to everybody. That's the main difference, I think, compared to previous genetic modifications. So it becomes a much broader debate, especially for second and third world countries. Emerging economies have a competitive advantage potentially, because they are not so heavily invested in the petrochemical industry. They can much more rapidly adjust their industrial production streams to a bioeconomy. They have much more to gain from synthetic biology than we have in the West in developed societies, and they have far less to lose. So they will certainly have to be involved. And there's another very important aspect. We are using in synthetic biology genes as if they are Lego bricks. We are assembling the parts of living systems in a combinatorial way to create new organisms. But we are not doing that from scratch. We are building on the genes and genomes that we find out in nature. And a large part of the biodiversity that produces this raw material for synthetic biology lives in the developing world, in the tropical rainforests, in coral reefs, in places that are populated by vulnerable populations that could benefit from getting synthetic biology royalties, basically, for the genes that are used for industrial purposes elsewhere. But we need mechanisms to ensure that.
So it's really important we bring all of those different parts of the world together when we start to think in the future of what synthetic biology will be doing in the world and who will be involved.
Yes, it's definitely an international debate, and it must increasingly become an international debate at all levels. It includes NGO debates. They have to take into account that it's not just a luxury problem. It's not a question that you can decide in industrial countries alone. You have to involve all the societies all over the planet, but also for industry, of course. They will also move their industrial production processes around. Biotechnology is much more mobile than other technologies. You can create the raw materials almost anywhere where you can grow a bit of plants.
So we could maybe finish with a final question that's about the role of industry in commercialization. So we've talked about large pharma and petrochemicals. What kinds of companies are going to be involved in the frontier of this cutting edge technology?
Synthetic biology will see a movement of genetic modification technologies from big pharma companies to a much broader range of applications. Much smaller enterprises can realistically embark on synthetic biology projects for their own purposes. You can create custom-made chemicals, specialty chemicals for very small market volume. Previously, GMOs were only feasible economically if you had a huge market that was justifying a very big investment. Synthetic biology makes all of that much easier accessible. It lowers the threshold and makes it possible for companies to do that would never have concerned themselves with genetic modification before.
Professor Breitling, that's really, really helpful. Thank you for your time today. And we'll be working again together on this with all these different societal actors, I know.
Thank you.
Thank you.